Hi, my name is Fet Penkov and I'm the creator of Efemarai. Efemarai is the first of its kind tool for debugging machine learning code. In this video, I'm going to show you a quick demo of how Efemarai works and what it can do. For this purpose, we're going to debug the implementation of a convolutional neural network implemented in PyTorch. You can see the actual code on your left, and this is a fairly standard machine learning model with several convolutional and linear layers connected with some nonlinearities. At the bottom, you see a typical training procedure, which when we run on this particular implementation, we get none values only after a couple of iterations. Now, none values are a very standard problem, and every machine learning practitioner faces them almost on daily basis. The problem is, though, that it's such a hard problem to debug because there are quite a few things that could have gone wrong, and it's really hard to figure out what is the actual cause of the none values that we see. So how can Efemarai help in this case? Well, the first thing to do is we go to the website, we launch the tool, and then we go back to our code and tell Efemarai to scan our model. To do this, we simply put the statement with Efemarai scan and we pass the iteration number. Now, having done this change, I'm going to run the code again, and on the right you see the full computational graph constructed by your model, visualized in 3D. Every single grayish box corresponds to some data. In this case, the big gray box here is our input image, and we can tell Efemarai to visualize it as such. Every blue box corresponds to a function, and as you know, functions can call other functions within, so we can click and expand on functions until we get to the bottom, and now we see the convolutional neural network that we've implemented. We can keep expanding various nodes here and there until we see the full computational graph, and we have access to any single value that our network consumes to generate its output. We can also access the gradients that the network uses to train its parameters simply by pressing G, and now we have access to all those values as well. We can now inspect any single value that the code consumes or generates simply by choosing the tensor, hovering over it, or exploring it to figure out what really went wrong. Now, going back to our none values, we can look at the bottom left corner that there is an error shown, and the error says positive input detected. If you hover on it, it highlights some nodes in the graph, and in this case this is the output of our graph. So if we zoom, we can see that this is the node here, and the node is the negative log likelihood loss function, and the error reads positive input detected. So our tool Efemarai has detected that we feed positive values to a function that actually accepts only negative ones, and in pretty much seconds we've detected what was the cause for the none values that we see. To fix this, we only have to do one single change in our code. We have forgotten the softmax function, and this is it. We've debugged this implementation in seconds, whereas it would typically take minutes, even hours, or maybe even days, depending on the complexity of the problem, the model, and the data. These were just some of the basic core functionalities of Efemarai, and if you're interested in the tool, make sure to visit the website and even start your free 30-day trial. Thanks for your time.